In this video we explore the need for virtual memory in a computer. When programs and data are being fetched and executed by the CPU, they are stored in the RAM. However, this assumes that the memory is large enough to hold the programs being executed. In modern computers, it is common to have more than one program open at once. For example, here we have the operating system and we have a word processing app taking space in the memory. However, you can store significantly more programs on the hard disk compared to the RAM because byte for byte hard disk space is much cheaper than RAM. When you turn the computer on, the Bootstrap program will load the operating system from the disk into RAM. When you use a computer, every time you double click an icon to load a program, it transfers those instructions into the RAM. But what happens when you run out of RAM? For example, here we've got the operating system and the word processor and a spreadsheet application open all at the same time, and we've run out of RAM. Now we want to also open our graphics application, but where can it go? Well, because the computer can only execute one instruction at a time, it means that some of the instructions are not likely to be fetched in the near future. Therefore, one solution is to transfer instructions that are not being used to a space on the hard disk. This is known as virtual memory. So for example, we could move our word processing app and our spreadsheet app out onto the hard disk, and then we'll have space for our graphics application in memory. Now of course, in a multitasking operating system you would want to switch between the word processor and the graphics application. Therefore, when the instructions for the graphics application are not being executed, that can be transferred out onto the virtual memory, and our word processing app can come back in to the RAM in order to process the next instructions. So we're using part of the hard disk space as if it was the memory. We can't actually execute the instructions from there because it would be too slow. We do need to transfer them back into the RAM, but we can at least pretend that we've got more RAM available than we actually have. This enables the user to have more than a number of programs open at once, and they all still to operate even though you don't actually have enough physical RAM for that to happen. So this gives the impression that a computer has more memory than it actually has. Virtual memory is needed when there's not enough physical RAM to store the open programs. Virtual memory is held on the hard disk. Programs are transferred out to virtual memory from the RAM when they're not currently being executed. Programs are transferred back to the RAM from virtual memory when they're needed. This is an oversimplification of what's actually happening, but it's enough to understand the basic principles of why there's a need for virtual memory.